Hello, and welcome to Backer Breaks It Down. In this episode, I want to look at power functions and something called variation. Okay, uh, so we're going to do some word problems, but these are pretty easy. Trust me. Okay, so variation, there are actually four types of variation. We have direct variation, inverse variation, combined variation, and joint variation. So direct variation. So you're reading a word problem, you're going to read something like y is directly proportional to x, or y varies directly with x. Okay, so whenever you read such a phrase, you're going to write a power function equation that looks like this: y equals k times x to the a power. So as soon as you get, and what's nice is that the words kind of like tell you exactly what you need to write down. All right. So when they say like y varies directly, you're going to write y equals k times. And then they'll tell you with x, and they might use some wording that indicates an exponent. So just listen for that. Okay. But the y varies directly part, that's when you write down y equals k times something. Okay. Inverse variation. So we read y varies inversely with x. Okay. So when they write down y varies inversely, you're going to write down y equals, and you're going to do k divided by. And then you're going to have to, like, obviously write down something for the x part. Okay. But y varies inversely as, you're going to have y equals k divided by something. Combined variation, both of these things are happening at the same time. So like y varies directly as x and inversely as z. So we're starting with that whole like y varies directly as, and so we're writing y equals k times something. And then and inversely as z, like that implies that we need like a division bar. So like maybe go like this: y varies directly as x and inversely as z. So the y varies directly as x part is y equals k times x. And then when they say inversely as z, we do divided by z. Okay. Joint variation is just you're multiplying by maybe two things instead of one. So y varies jointly as x and z. We're going to write y equals k times x and z. So jointly also indicates multiplication. Okay, so we multiply with jointly, we multiply with directly, we divide with inversely, and we do both for that combined variation. Okay. And so the way the wording is in these problems, everything is in order. I really like it. Okay. And what I like to do is I like to use a highlighter, or I don't know, maybe I just underline, and I like to identify like all the variables in the problem and any keywords. And then I go and I write my function equation. Okay. So that's what I'm going to do here. So this said x varies jointly as y and the square of z. So those are like the key terms in that expression. So now I'm going to translate that into a power function. So they say y varies jointly as, x varies jointly as, and x equals, and jointly is multiplication, so k times, and then they say as jointly as y, and the square of z. So that'd be z squared. And that is my power function. X equals k times y times z squared. And so everything is there, it flows naturally and in the proper order. So I would read the expression first, highlight or underline any key terms, variables, and then write your power function. So taking a look at number 2, x varies directly as the cube of z and inversely as y. So now I'm going to put all those things together, right? So I got x varies directly as, so that's going to be x equals k times, because directly is multiplication. And then it says the cube of z. So the cube of z is z cubed, right? And inversely as x. I'm sorry, and inversely as y. So then, and inversely would be division by y. And so there you have it, x equals k times z cubed divided by y. So don't let 3 and 4 intimidate you. Yes, there are more words there, but the idea is still the same. So in number 3, the distance d of an object from a planet is inversely proportional to the square root of the gravitational force F the planet exerts on the object. Okay, so d inversely square root F is essentially all you really care about, right? So we got d, and it's inversely proportional, so that's division, so k divided by the square root of f. So the square root of f. One more, okay? Maybe you want to pause, try it, and then check in with me. The work done W in stretching a spring is directly proportional to the square of the distance d that it is stretched. So W directly square d. Got it? So W directly, so equals k times the square of d, d squared. Okay, so it's really easy to write the power function equation. Okay, so directly is k times, inversely is k divided by, and jointly is k times 2 other things. And that is how Becker breaks it down.